Okay, here I am again. I just did the other section, but I figured I might as well do this one while I'm here. So we're also now going to do section 9.6, page 384, more scientific notation. So hopefully this will be really quick for you and not be too terribly difficult because it's very similar to what we did in the last section, only this time we're taking a standard number and we're turning it into scientific notation. Okay, so let's start with example number 1. One thing I try to remember is if I have a really big number, I'm going to have positive exponents. And if I have a really tiny number, I'm going to have negative exponents. Just like the rule I told you about in the last section, that same one applies. So it's kind of a way to double check ourselves and make sure we did the right thing. Okay, so let's look at example number 1. We are supposed to take the number 50. Okay, 1, 2, 3, 1, 2, 3. And change it into scientific notation. Okay, so this is what I do. I put my decimal at the end of my number. And remember, to be in scientific notation, my decimal really has to be after this first number, right? So we're going to count how many positions it is to get from where my decimal is now to where my decimal is where it should be. 1, 2, 3, 4, 5, 6, 7, 8, 9 positions will get me to where my decimal needs to be, right? Which is right after that first number, okay? So since that was 9 positions, my exponent is a 9. Really big number, positive exponent. Okay, let's look at 2. In 2004, the Indonesian earthquake slowed the rotation of the earth, making the length of the day, okay, oh boy, 0.1, 2, 3, 4, 5 zeros. I got 5 zeros there. 1, 2, 3, 4, 5, 268. Okay, really little number, so we're going to use a negative exponent, right? So remember, our decimal needs to go right after our first number, which means it needs to go right there. So let's count. 1, 2, 3, 4, 5, 6 positions to get it where it needs to be. And because it's a really little number, I'm using a negative exponent for this one, okay? So however many positions you have to move, that's the number you put as your exponent. If it's a really big number, you have a positive exponent. If it's a really little number, you have a negative exponent. Okay? All right. So let's look at example 3. An album has sold 8,780,000 copies. That's a lot of copies. Okay. 8 million, I already forgot the number, 780,000. Okay. And how many more copies does it need to sell to receive the award? Again, information is always under the picture. So let's go into the picture. It gets an award after it sells 10 million copies. So how would I figure out how many more it needs? You're right. I would take the total to get the award minus what I already have sold to get how many I need to sell. Okay, so I get 1,220,000. But all of my multiple choice answers are in scientific notation. But that's okay because I just taught you how to switch it. So here we go. My decimal's right here. I'm going to need to move it 1, 2, 3, 4, 5, 6 positions to get it right after the first number, right? Did you count with me? Did I go 6 positions? And it's a big number, so would it be a positive or negative exponent? Positive, right? Okay, is that one of my answers? C. Perfect. C it is. Okay, example number 4. So in example number 4, we're going to be multiplying some exponents. And I mean some scientific notation numbers. It's no problem. I don't want you to necessarily just plug them into your calculator, okay? I want you to kind of make sure you know how to do it out yourself instead of just plugging the numbers into your calculator, because next year when you're in algebra, I'm not going to let you necessarily use your calculators for some of this stuff. So I need you to kind of know how to do it without just plugging the entire problem into your calculator, okay? So let's look at example number 4. It's 3 times 10 to the -5th, and that's getting multiplied by 5 times 10 to the -2. Okay, so when I'm multiplying scientific notation, what I do is I multiply my real numbers first. That color is really hard to see, huh? Real numbers. So what's 3 times 5? That's 15, right? Okay, so far so good. Multiply the numbers first. Now, remember when you're multiplying exponents with the same base, let me write it up here. This is really 10 to the negative 5th times 10 to the negative 2, right? That looks familiar to you. They have the same base. So what do I do to the exponents in this case? Do you guys remember when you're multiplying? You're going to add those exponents, right? So that would be to the negative 7. And this is now close to scientific notation, but those of you that have been paying attention and realize that it's not quite scientific notation because my decimal is not right after the 1. It's after the 5, right? So we need to take care of that. And the way they show you to do that is to go ahead and take this and turn it into scientific notation. So if I'm going to turn that into scientific notation, I need to move it 1 position over. So that would look like that, right? I moved it 1 position. This number I turn into scientific notation. Then I multiply it by the one I already had. So let me say that again. When my number is not in scientific notation, I need to change it into scientific notation, but then I still have to remember I have that 10 to the negative 7. And some of you will learn this process and you'll be able to shortcut it without having to write it all out. But we're going to write it all out. So my 1.5 is now correct. Now again, I'm going to add my exponents. What's a 1 minus a 7? A negative 6, right? So now I have written it correctly in scientific notation. Notice the difference here. This was a 15, this is a 1.5. Notice I only moved it 1 position, so I changed my exponent by 1. If you can't remember what to do with that, go ahead and write this in scientific notation, which I did right here, and then combine it with the one I already had up here, okay? And that's how you multiply. Multiply the regular numbers, add your exponents, and then change it if it's not in scientific notation. Okay, I think that's it for today's section. Short video, so hopefully it goes well. Good luck with your exponents and your decimals, and remember to use commas. Okay, we'll see you later. Bye.